Okay, this is 8G6, 8th grade geometry standard 6, video 1, square roots. And we are going to be talking about the Pythagorean theorem and its converse in the very near future before we get into actually doing the Pythagorean theorem, which is what I have written on the board here. I think it would be important to talk about what a radical expression is, what a root is, what a square root is. We'll talk about perfect squares and then maybe talk a little bit about approximating square roots, which we did earlier in the year, but it might be a good time today to give you a quick refresher on that. So in video 1 here, we're going to focus in on radical expressions and square roots. A few terms I'd like you to know. Please jot these down in your journal and define them. All right, finding the square roots of a number. So if I were to find the square root of 25, I'm gonna put the radical symbol over the 25. And what that's asking is, what number multiplied by itself is equal to 25? So you're thinking about what number multiplied by itself. So I guess we could call it A multiplied by A is equal to 25. So what can we replace in there as a root? Right, 5. I could replace this by a 5 times a 5 because positive 5 multiplied by positive 5 is equal to positive 25. And I also want you to be aware of the fact that negative 5 could also be the root. Think back to your integer rules for negative. So if I were to say negative 5 times itself, does that also equal positive 25? And the answer to that would be yes. So the roots of 25 would be, I guess you can write it a shorthand way of positive negative 5. Final answer right there. Okay, next one, 81. So the square root of 81 is equal to, that would be on our perfect square chart. We have a number multiplied by itself that's not a decimal. These are all whole number answers of what? So we would have 9 times 9 and negative 9 times negative 9 would get us 81. So answer positive and negative 9. All right, 144 is also on the perfect square list. The square root of 144 is equal to positive 12 and negative 12. I chose the last one here because I want to take a little time to refresh your minds on these numbers that aren't perfect. Common error right here, the square root of 2. Common error, people would say, oh, it must be 1, and it's not adding. You cannot say 1 plus 1 is equal to 2 as a root. You're doing a product. So what number multiplied by itself is equal to 2? And this is going to end up being a decimal, a very long decimal that would need to be rounded. But what I want to talk about today is leaving it in radical form. When we go back to this Pythagorean theorem right here, we are going to be leaving some of our answers in radical form because they aren't going to have that perfect square answer to this. And we'll get into that in the next video when we start talking about the theorem and also its converse. All right, so for today's purposes, we know that it is the square root of 2 final answer. All right, the last part on the next 2 screens, we're going to deal with solving equations that are involving squares. And think all the way back to when we were solving equations in 1 step or 2 steps using inverse operations. Well, this is also an equation that has an inverse operation, an opposite operation. And we always want to get this variable down to 1x. You know, whatever your variable is, we want one of them. We want it to be a positive variable, and we want it to have a coefficient of 1 in front of it. And right now we do have that 1 coefficient. The problem is we have this exponent that does not relate. It is not x to the first power. It is actually x to the second power. So what is the inverse operation that gets rid of this exponent to the second power? Well, think about what it's saying. It says x squared is equal to 49. X squared means what multiplied by itself is equal to 49. And we just learned on the last screen that we would have two values that would actually work, positive and negative 7s. So how would you show your work on this? Well, if I were to undo this square, the inverse operation would be a square root. And if I were to balance the equation like we've always done, if I take the root of the left side of the equation, I must also take the root of the right side of the equation. All right, so the square root of x squared would just be one of them, and the square root of 49 would be one of them, which is 7, or we also learned that x could be equal to negative 7. So two possible answers here. All right, the next one, we have a coefficient that is not a 1. And we have learned in solving equations to get rid of this coefficient that is touching the variable. We do the opposite of that operation. Well, this is multiplying right here, and the opposite of multiplying is dividing. So we would divide both sides by 2. All right, the 2's will cancel, and you're left with y squared being equal to 100. A common mistake would be stopping there, because you know we don't have the value of y. We have the value of y squared. So think about what you would do to both sides in order to solve for y. Good. The opposite of squaring a number is taking the square root. Whatever you do to one side, do to the other. So the square root of y squared is y, and the square root of 100 is positive and negative 10. Now you're going to notice we've been talking a lot about this negative root. When we get into the Pythagorean theorem, we are not going to be using that negative root, because in the theorem we're dealing with distances, the lengths of a triangle, you know, side lengths, and you cannot measure distance or lengths of polygons with negative numbers. They just don't exist. So at some point in the next video, we are going to be rid of this idea of the negative root of numbers. But for today, it works. All right, last one. Now I've got it looks like a two-step equation with the possibility of a third step in that exponent of 2. All right, so we draw the wall as always. Draw the wall right down the equal sign, and think about who you're going to get rid of first. You've got this product of a 2 coefficient, and you've got this subtraction of a 3. And you remember that we get rid of this 3 first, so the opposite of subtracting 3 would be to add 3. So we take our 2h squared, there's our minus 3 that we began with. To get that negative 3 to a 0, we add 3, which means I have to do the same thing to the other side of adding 3. All right, next step, 15 plus 3 is 18, and that's equal to 2h squared. And recall that that's a 0 now. We got rid of that. Next step, get rid of that 2 coefficient that's touching the h squared. Divide both sides by 2. And we are left with h squared equaling 18 divided by 2 is 9. Don't stop there. I don't want h squared, I want h. So we take the square root of both sides of the equation, and h is equal to positive and negative 3. And we'll leave it with both roots for today, and like I said before, when we get into the theorem, we'll get rid of that negative root. All right, in your journal, please define the given terms on page 2 of the flip chart. Write a few sentences on what you learned from this video, and if you have any questions, put a little marking in your journal or anywhere that I spoke of an example or an idea that you didn't understand. Please make a marking in your journal and bring those questions to class, and we can all answer them together.